right? Good morning, students. Yeah, limits is going on. Just now started. Limits. Okay. today, lecture 3. So now we are in only introduction part, fundamentals. Yesterday I have explained that how we will find out the limit of a function and what is left hand limit and what is right hand limit. Now today we will learn so many elementary concepts regarding limits. Okay. Now existence of limits, right? So existence of limits. Existence of limit. Existence of limit. This is an important thing. Remember. A function, or I can say that limit x tends to a, f of x is said to exist, if its value, if both left hand limit, right, and right hand limit, alright, must be same and equal to some finite number, where L is a finite, where L is a finite. Alright. So when we say that a limit is said to exist if both left hand limit and right hand limit equal, must be equal, and that should be a finite number. Right? It's a finite real number. Of course, we are in only real number system. Otherwise, we say that limit does not exist. Here I am writing, if limit x tends to a minus f of x not equal to limit x tends to a plus f of x, then we say that limit x tends to a, f of x does not exist. This is important. Does not exist. Alright. Okay. So this is the point number 1 and this is point number 2. I can give you very simple kind of examples regarding does not exist. Limit does not exist. Here I am writing. Example 1. Limit x tends to 0. Mod x by x does not exist. Why? Does not exist. Why do so? We will see that. So this is the given limit. So for the existence of limit, we need to find out left hand limit and the right hand limit. They must be equal to same finite number. Okay, first we will find out left hand limit. So left hand limit, we write LHL. Limit x tends to 0 minus, right, mod x by x. X tends to 0 minus means x takes values left side of 0. So here x is negative. When x is negative, mod x becomes minus x. So x tends to 0 minus, you will write minus x by x. That's equal to minus 1. Right? Now let us find out the right hand limit. Right hand limit. Limit x tends to 0 plus, right? See, mod x by x. X tends to 0 plus means here x is positive. So when x is positive, you write mod x equal to x. So limit x tends to 0 plus, you will write x by x, that you will get 1. Right. So therefore, when you are approaching 0, that function is not approaching a unique number. Right. So therefore, LHL is not equal to RHL. Hence, limit x tends to 0, mod x by x, or limit x tends to 0, you can say that root x squared by x, both are same, does not exist. I think you are understanding. Now, I will give you one more example. You see. Show that limit x tends to 1 minus, alright, integral part of x plus modulus of x minus 1 does not exist. Does not exist. Alright. Okay, limit x tends to 1, integral part of x into modulus of x minus 1 does not exist. Let us see. Okay, first we will find out left hand limit. Limit x tends to 1 minus. Right? Okay, integral part of x plus modulus of x minus 1. So x tends to 1 minus is nothing but x takes the values left side of 1. You can take 0.999. Then what is its integral part of x? It is 0. So this value is 0. Plus you can substitute 1 here. That's equal to, substitute 1 here, you will get 0. That's equal to 0. So here you have taken both left hand limit and right hand limit, but here you have not considered that modulus of x minus 1. Right. Here you see, this is never be negative. This is always greater than or equal to 0. What about this one? This is not always greater than or equal to 0. Here numerator is greater than or equal to 0, but denominator, when x positive, entire thing is positive. When x negative, entire thing is negative. So we are getting positive value, negative value. That's why I have taken left hand limit and right hand limit. And what is the right hand limit now? I think you can write directly. Right. Limit x tends to 1 plus integral part of x plus modulus of x minus 1 equal to, put x 1 plus means you take x equal to 1.00001, then integral part of x equal to, you will get 1. 1 plus 0 equal to 1. So therefore, right, LHL is not equal to RHL. Hence, limit x tends to 1, integral part of x plus modulus of x minus 1 does not exist. Does not exist. You write down. piecewise function. I will give you one more example for a piecewise function. Here is example 3. If f of x equal, you take some that x square plus 1 for x less than 1. Alright, and the sum 2x plus 3 for x greater than or equal to 1. Alright, okay. Or I can say this is for x greater than 1 and its value is some 0 when x equal to 1. Then check existence of limit x tends to 1 f of x. Check the existence of limit x tends to 1 f of x. Means whether it will exist or it does not exist. Alright. So here you see that function is defined as a piecewise function. Means in different intervals they have defined different functions. To the left of 1, the function is x square plus 1. Alright. So left hand limit means f of 1 minus. You write limit x tends to 1 minus. You take that x square plus 1. You can substitute directly x equal to 1 here. You will get 2. Similarly, RHL equal to f of 1 plus. You have to take that limit x tends to 1 plus means x is more than 1. Then you take 2x plus 3. You will get 5. So therefore, LHL is not equal to RHL. Hence, limit x tends to 1, f of x does not exist. Does not exist. So in this way, we can take several examples. Right? You have to practice some questions. It will take time. From tomorrow onwards, you can practice the question. You write that one. So this is a piecewise function of finding existence of limits. It is very simple. You can practice this question. Let f of x equal to a square into integral part of x, right, plus x into mod x, okay, or I can say that, okay, no problem at all. This is for x less than 0. Alright, okay. Next one is a into modulus of x by x. Alright, plus I can say that or 2 times of integral part of x plus 2 for x greater than 0. Alright, and it is some thing like you can say it is 0 then x equal to 0. It is not necessary. If limit x tends to 0 f of x exists, then find a. Alright, So here a small printing mistake. So this is LHL is not equal to RHL. So that is corrected. Okay. Corrected. All right. Now a few points I will tell you. Today I have to finish many things. Note. All right. You see. Let F be defined. F be defined in A comma B. Let C belongs to, all right, open interval A comma B. Means C is an interior point of A and B. Then limit x tends to C exists and equal to L belongs to R if both left hand limit and right hand limit exist and must be equal. So when the point is an interior point, then we have to discuss both left hand limit and right hand limit. Remember, when the point is interior point. When the point is interior point. Second one. Right. Okay. For the same, here you see limit in the above case, limit x tends to A. F of x means limit x tends to A plus f of x. Because there is no left side of A. There is no graph left side of A. Let f be defined in A comma B. Alright. X tends to A, f of x means you have to take right side of A. You need not to think about the left side of A. Limit x tends to A. Let us take B. So we are at left side of B. So we have to discuss only x tends to B minus f of x. You should understand according to the situation. Right? Okay. For example, here I am giving an example. Limit x tends to 2 plus, or I can say limit x tends to 2 root over, I can say that 4 minus x square equal to dash. Limit x tends to 2 root over 4 minus x square is dash. See, here that 4 minus x square should be greater than or equal to 0, implies you will get x belongs to minus 2 to 2. So x is defined between minus 2 to 2. means left side of 2 graph exists, but there is no right side of 2. So therefore, limit x tends to 2 root over 4 minus x square equal to limit x tends to, you think that it is 2 minus, right, root over 4 minus x square. After that you substitute directly x equal to 2, no problem at all. You will get 0. But if you think that if you substitute any value right side of 2, then it will become imaginary number. At that time you should not say that limit does not exist. That is absolutely wrong. Here the domain is minus 2 to 2. So limit concept always will be discussed within the domain of the function, even though function is not defined particularly at that point. But the graph of f of x should exist either left neighborhood of a or right neighborhood of a. Alright, okay, you write down. That I will explain deeply later. You will not understand now. You can think like this. You see, I will give you one more example. Of course, you can understand it. Limit x tends to 0, ln x equal. Limit x tends to 0, ln x. Anyway, ln x is not defined for x negative, isn't it? Ln x is not defined for x negative. So the physical meaning of this statement is, it is forced to evaluate x tends to 0 plus only. With the graph, you can tell your answer. You see, this is the ln x graph. Alright? Y dash. Y. When you are approaching 0 from right side, your values are drastically getting down towards minus infinity. Therefore, this is equal to minus infinity. So, if you know the graphs perfectly, so many limits concepts you can understand very simple. This is a very, very important thing. So here I have wrote that infinity, right? So I have to give some definitions, right? So infinite limits. Infinite limits and limits at infinity. And limits at infinity. All right. Well, so let us think that what are the infinite limits. So I write the definition in as usual way. Okay. Once again I am telling, you must have a good command on elementary graphs. Okay, one. See. F of x is said to tend to infinity, right? As x tends to a. Of course, here we always assume that f is a real valued function. I don't write every time, right? F of x is said to tend to infinity as x tends to a if for each given g greater than 0, however very large, right? So if for each given g greater than 0, there exists a delta greater than 0 such that f of x is greater than your number. F of x is greater than your number, right? Because you are giving a number g. So if every time f of x passes your number, then we say that it is tending to infinity, right? Whenever 0 less than modulus of x minus a is less than delta, means in the deleted neighborhood of a, the function should be tend to infinity, means it should possess all limits, means whatever large number you give, that f of x should go beyond your number. Then only we say that f of x tend to infinity, right? I'll give you an example. You see, limit x tends to 0 plus 1 by x equal to, we write infinity. Limit x tends to 0 plus 1 by x equal to infinity. How it happened? Let us see. I'll take a formal, means I'll take simple example. You are approaching 0 from right side, right? You take x equal to 10 to the power of minus 10. It is very close to 0 because 1 by 10 power 10. Then what will be the 1 by x value? It will be 10 to the power of 10. If you take 10 to the power of minus 100, 1 by x becomes 10 power 100. If you take 10 to the power of minus 10 to the power of 10, then you will get 10 to the power of 10 to the power of 10. Like that, in this way, you are getting close to 0 plus, whereas 1 by x is tending to very large number. That large number, we say that infinity. I haven't explained that how do we apply this concept. Now not necessary. Just I am giving the definition because once you get into engineering, there you should not feel difficult. Right. Now only you can understand. So which means that you have to give a number. For example, you see, I will explain. You don't worry. So somebody has given, suppose somebody has given g equal to 10 to the power of 10 to the power of 10 to the power of 10. This is given by you. This is given by you. If I am able to show that the value of 1 by x is more than your number, then definitely that number 1 by x tends to infinity and x tends to 0 plus. See, okay, 1 by x must be greater than g, that is 10 to the power of, you can say 10 to the power of 10 to the power of 10. Alright. Okay, anyway x is positive. So you just put this send this number this side and this thing. Then you will get x is less than 10 to the power of minus 10 to the power of 10 to the power of 10. Alright, you got my point. So now I have to find the delta. At x equal to 0. At x equal to, see, here a value is 0. So now 0 less than modulus of x minus 0 is less than delta. Anyway, x is positive, x is less than delta. So therefore, choose delta equal to this number only, 10 to the power of minus 10 to the power of 10. Which means that in the neighborhood of 0, this is 0 right side only, 0 plus delta. If you take any number between, which means that that this is 0 and this is 10 to the power of minus 10 to the power of 10 power 10. In this interval, if you choose any x value, that 1 by x value is more than your number. 1 by x value is more than your number. For example, you take that 10 to the power of minus 10 power minus 10 power 10. You take this is belongs to 0 to delta. Then 1 by x equal. You will get 10 power 10 power 10 power 10 power 10. It's almost getting tending to infinity. So there is such a logic and very deep concept is there. Of course, it is very difficult to digest immediately, but gradually you will learn it. So for the rest of the things, I will write the definitions directly. I won't explain all these examples. You write them. Well, okay. So this is the case where we use that f of x tends to infinity. And one student has sent me that, sir, please explain that ln x case. There is nothing to explain. This is the graph you are seeing. Okay. When x approaches to 0 plus, your value is tending to minus infinity. Okay. Anyway, you have asked me, so I will tell you. I will give you 1, 2 values. So x tends to 0 plus. So you take x equal to like that 10 to the power of minus 10 power 10. Let us take this. What is ln x value? Right? Or I can say that its value is e to the power. Then ln x equal to, you will say minus 10 to the power of 10. If I take x equal to e to the power of minus 10 to the power of 100 power 10, it is 10. It is almost tending to 0. It almost tending to 0 plus. Very close to 0. Then what is ln x? Ln x equal to minus 10 power 100 power 10. So this is a very large number, and before that negative sign is there. It is almost tends to minus infinity. Okay, so that I am writing here. So the second one is limit x tends to a, f of x equal to minus infinity if for each given g greater than 0, very large, there exists a delta greater than 0 such that f of x is less than minus g. F of x is less than minus g whenever 0 less than modulus of x minus a is less than delta. For this, an example is very simple. Limit x tends to 0 minus 1 by x tends to minus infinity. Right. Okay. Same case, you can explain the same way. Right. Limit x tends to 0 minus 1 by x tends to minus infinity. Means you take the values to the left side of 0. You will get negative of infinity. Similarly, limit x tends to 0, I can write 1 by x squared, you will get infinity. So, y equal to 1 by x graph will be like this. When x tends to 0 plus, you are getting plus infinity. Right? Okay. That I am writing here, this is the case. You are going upward. When you are approaching 0 from left side, you are getting down like this. So this is the graph of y equal to 1 by x. For the case of 1 by x square, anyway it is an even function, so it should be symmetric about y axis. So the graph will be like this. This is the graph of y equal to 1 by x square. You write down. So you try to practice all these graphs. Don't leave them alone. Later on you will struggle a lot. I can give you one more example that limit x tends to 0 log mod x, you will get minus infinity. Whether x tends to 0 plus or x tends to 0 minus, in both the cases you will get minus infinity. So I have to tell you a few graphs that I will explain when I discuss the concepts of continuity and differentiability. At that time, I will tell you how to draw the log mod x, modulus of log x, etc. So now third concept is limit x tends to infinity. F of x equal to L. L is finite. L is finite. Okay. If for each given epsilon greater than 0, there exists a g greater than 0, very big number. A g greater than 0 such that modulus of f of x minus L is less than epsilon. So whenever limit is finite, we always follow this inequality. Whenever x is greater than g. See, here we want that f of x tends to infinity. That's why we wrote that f of x greater than g. And x is tending to a small number. Here f of x is tending to small number. but x is tending to infinity. So the roles will be reversed. Here I wrote x greater than 0. Alright. Okay. So this I will give you an example also. Limit x tends to minus infinity. F of x equal to L. Right. If for each given epsilon greater than 0, there exists a g greater than 0 such that modulus of f of x minus L less than epsilon whenever x is less than minus g. X is less than minus g. Let us take an example. Here you see, what will be limit x tends to infinity 1 by x value. Right. As x tends to infinity, 1 by x tends to 0. That is obvious. Both are reciprocal cases. When x tends to, as x tends to 0 plus 1 by x tends to infinity. As x tends to infinity, 1 by x tends to, of course, particularly 0 plus. Both are same. Right. Similarly, limit x tends to minus infinity. That 1 by x, again you can write 0. Whether x tends to infinity or x tends to minus infinity, in both cases that 1 by x tends to 0. But one approaches right side of 0, other one is approaches left side of 0. You observe this here. When you are moving x like this towards infinity, your values are dropping down. Your values are dropping down towards 0. When you are moving x to the negative infinity, like this, right, your values are increasing towards 0. But in both the cases, you write 0. Write down. Well, so these are all basics and elementary things. So you must be very careful. If you do not understand these elementary things, you cannot understand the entire calculus. Write each and everything on your notes. You will forget. Okay. So here you see. So limit x tends to infinity, 1 by x is 0. Limit x tends to minus infinity, 1 by x is 0. Alright, here I am writing limit, okay, I will do one thing. I will write, two more is left. Limit x tends to infinity. F of x equal to infinity. Right? limit x tends to infinity, f of x also tends to infinity if for each g greater than 0 there exists a m greater than 0, very large, right? Because both are large quantities, such that f of x is greater than g, your number, for all x greater than m. Right? Okay. Similarly, I can write a limit. There are functions, limit x tends to infinity. You can have f of x equal to minus infinity. I don't write all these definitions. Limit x tends to minus infinity. You can have f of x equal to infinity. And limit x tends to minus infinity. You can have f of x equal to minus infinity. All possible cases are there. Right? Okay. Now you see. One example I am writing. Limit x tends to a. What will be 1 by x minus a? Alright? This does not exist. You have to say that does not exist. Limit x tends to a, 1 by x minus a does not exist. Why? I will tell you. Solution quite simple. First I will find out left hand limit. Means limit x tends to a minus 1 by x minus a. Alright? Okay. That's equal. Okay. This I can write limit x tends to a minus means x is less than a. Alright? So I can write that x minus a tends to 0 minus 1 by x minus a. Right? So what will be x? See, you can assume this as a sum y or sum t. I can write limit t tends to 0 minus 1 by t. Remember, this is minus infinity. Right hand limit. I can write directly here limit t tends to 0 plus. X tends to a plus means x is greater than a. So x minus a is positive. 1 by t, you will get plus infinity. One time you got minus infinity, other time you got plus infinity. Therefore, LHL is not equal to RHL. Hence, limit x tends to a, 1 by x minus a does not exist. I hope you are understanding. I can draw the graph. You can say that. Suppose a is positive. If a is positive, okay. When you are approaching a from left side, you are approaching towards minus infinity. You are approaching towards minus infinity. Right? Okay. When you are approaching a from right side, you are approaching towards plus infinity. Alright. So the graph will be like this. That is 1 second. Right? Assume a is positive and the other graph is like this. This assume y equal to 1 by x minus a. When x is 0, y value is minus 1 by a. That is negative. This value is minus 1 by a. This is x axis. Later on, you will come to know the importance of these graphs. You write down. So this Saturday, anyway, you will have the class. because I have taken more time to explain all these concepts. But I didn't give any examples, I think, for this. I'll give you. Limit x tends to infinity. E to the power of x is also infinity. Limit x tends to minus infinity. Alright, e to the power of mod x is also infinity. Alright, I can give you that limit x tends to infinity. Ln x tends to infinity. You can see the e power x graph. Here I am drawing e power x graph. Here you see. This is e power x graph. Right? When you are approaching infinity, x approaches infinity, this value is drastically increasing. Means x tends to infinity, e power x tends to infinity. Why? Because you are multiplying e, that is 2.718, infinite number of times. So you will get infinity. So you try to calculate limit x tends to, I can write 1 integral part of x by x minus 1, so that this does not exist. Does not exist. Yeah, time's up. Okay. I will tell you more about limits tomorrow. Tomorrow we'll start examples, so many examples. Right, thank you.